The Internet of Things is nothing short of a modern miracle. The ability to connect devices across a network and control them remotely, gathering data, performing routine maintenance, and saving countless hours of preparation time and direct human interaction. It gave rise to the need for smart, connected, and secure technology solutions. That's great for the residential home or the industrial plant across town, but could that level of sophistication and convenience follow us to other places like, say, the hospital? We are, in fact, living the future today, where a world of medical devices are no longer standalone entities, but interconnected nodes in a vast network known as the Internet of Medical Things. This digital revolution promises to transform patient care, enabling real-time monitoring, remote diagnostics, and personalized treatment plans. But these utopian dreams of a better health system still have some caveats to be aware of. As we embrace this new frontier, we must also confront the looming threat of cybersecurity, or cyber insecurity. In recent years, ransomware attacks have targeted healthcare institutions worldwide, from the WannaCry outbreak that crippled the UK's National Health Service in 2017 to the more recent Ryuk attacks on U.S. hospitals in 2020, like Locky in Los Angeles. According to the HIPAA Journal, at least 141 hospitals were directly affected by ransomware attacks in 2023 alone, where the number of attacks almost doubled since the previous year. These incidents expose the vulnerabilities in our medical device infrastructure, where outdated software and lack of encryption leave patient data and lives at risk. The American Hospital Association describes these not as white-collar crimes, but threat to life crimes, and they can be a life or death matter. Yet amidst these challenges, there is hope. As technology advances, so too do the solutions for securing the Internet of Medical Things, or IoMT. With development of purpose-built embedded control technology solutions, we stand on the edge of a new era in connected care. Imagine a future where medical devices not only communicate seamlessly, but also protect patient information from the most sophisticated attacks. How can Microchip technology strengthen and reinforce the Internet of Medical Things and potentially hold the key to unlocking a brighter, healthier future? Let's go beyond the microchip and hear a story of empowering innovation to enhance the human experience. Returning to the podcast is Justin Wilson. Justin is a technical marketing engineer at Microchip Technology working out of the Medical Products Group. He joins us today from our global headquarters in Chandler, Arizona. Welcome back, Justin. Thank you for coming back to Beyond the Microchip.
Glad to be back, Dana.
In the intro, we briefly talked about the Internet of Medical Things, IoMT, and the threats of cybersecurity in the medical device field. What can you tell us about it?
Yeah, so I'll start by kind of talking about the Internet of Medical Things and what that really means. So I'm sure a lot of our listeners are somewhat familiar with the Internet of Things. And the Internet of Medical Things is very similar. It refers to the collection, transmission, and analysis of data. Mm-hmm. In this case, it's medical devices collecting medical health data that is one of the more protected forms of data thanks to laws in place like HIPAA.
Like HIPAA, yeah.
Yep. And so what all of this collection of data does and allows for healthcare providers is to kind of just get a better overview of what's really going on with each individual patient. It's kind of just the idea of increasing the amount of data that's collected to use that data to improve patient outcomes, hospital workflows, and other things like that. And to kind of put that into perspective of why it's important is you think about how a lot of people kind of interact with their medical lifestyle. And a lot of the times, most people go to the doctor once a year. And in that one time, they'll get their vitals taken. And that's the one snapshot that a medical professional will get to kind of decide how healthy a person is over the course
of 12 months.
Exactly. And that's it for 12 months. And, you know, let's say if you go into the doctor before work one day, you have to get up a little bit earlier. Maybe you drink an extra cup of coffee. When you get into the doctor's office and they take your blood pressure and your heart rate, thanks to the caffeine and that coffee you just drank up, your numbers might not look too good.
You threw off your 12-month record.
Yeah, exactly.
Yeah.
And so that's the one kind of standard metric that healthcare providers will have for your overall health. until you come back next year. And maybe next time you won't drink as much coffee and it'll be completely different than it was the first time.
Okay.
So the root of the Internet of Medical Things really starts with remote continuous monitoring of patients, whether that is in a hospital or people managing chronic diseases, where you see remote continuous monitoring already becoming a pretty common thing. But it is also just expanding out to the everyday people who don't necessarily think that they're facing medical threats, but they could be in the future. And tracking this from an earlier point in time can help medical professionals work better with these patients to come up with better treatment plans, as well as just improving workflows and efficiency within the hospital. So then once all of this data is collected, you have to, once all of this data is collected, it becomes really valuable in terms of analysis that can be performed on this data.
Mm-hmm.
And so as you collect more data and you're storing it, a lot of the times this data will be transferred to something called an electronic health record, which is kind of just the hospital database for keeping track of patient records and things. And so another step in the Internet of Medical Things is applying analytics techniques, especially with the rollout of more powerful AI and machine learning algorithms to kind of sift through this data and figure out where things can be improved in hospital workflows, where certain health data points can point to a few different options for specific patients and lead to more personalized treatment plans, as well as kind of a future outlook of it is something called preventative medicine, where you can do this tracking before somebody knows that they will need medical intervention, and kind of predict where their health will be in the future based on these data points that you collected earlier.
Is this part of aggregating all of the different EHRs that are out there? Or?
It can be in a way, but a lot of the times these are just the individual healthcare organizations collecting their own data and kind of figuring it out on their own.
Okay.
Yeah. But of course, with any good thing, while the Internet of Medical Things is certainly pushing in a way that will improve patient outcomes and efficiency in the hospital, it also comes with a bad thing. And that bad thing is storing all of this very protected data in one centralized location, and then filling up a hospital and as well as putting devices in homes that can connect to the system. And that, in the eyes of hackers, is a gold mine, essentially.
Very sensitive data, yeah.
Very sensitive data. And so this is an issue, like you said, because cyber attacks are becoming more common in the United States as well as the rest of the world. And as you said earlier, I think it was 2023, there were over 140 different hospitals that were directly affected by a ransomware attack.
Yep.
And each of those attacks, about 60% of them were actually resolved through paying the ransom.
Right.
Just because in terms of what is going on with that hack, it's shutting down hospital critical functions. It could be canceling appointments, pushing out surgeries, things like that. And so a lot of the times it's just a lot cheaper and easier and more convenient to pay the ransom and move on with that. And the ransom cost, though, is not cheap. The average, at least in 2021, was around $1.3 million per ransom attack. And that's just the cost to pay off the hacker. The average cost of a medical data breach lies somewhere closer to $10 million when you include the investigation, the legal and regulatory compliance, as well as any credit monitoring that may have to go on afterwards due to patients' data like social security numbers and credit cards being leaked as well.
Yeah, it's one thing to hack the tablet interface on your Samsung fridge. It's another to get into the hospital system.
Yeah, exactly. Yep, you're getting your hands on a lot of sensitive stuff there. And so with all of that, it points to cybersecurity being very critical to medical systems. But if it was something that was easy, it would probably be done already, considering a lot of hospitals are dealing with these costly attacks, and it's happening more and more often. So there are a lot of difficulties that come with implementing cybersecurity within an Internet of Medical Things ecosystem. And this starts with just the trend of healthcare evolving to the Internet of Medical Things and using that as a kind of primary system within the overall health ecosystem. Because as more and more devices continue to connect to these hospital systems, the term that's thrown around is surface area. It's growing the surface area where every new device that you put into a hospital, it's connected to the internet in some way, opens a door and or unlocks a vulnerability.
Potential for a breach, right?
Exactly, a potential for a breach within a hospital. And where 10 years ago, it was estimated to be between 25 and 50% of hospital devices were connected to the internet. Today, it's closer to between 50 and 75%. And 10 years from now, it's projected to be well over 75%.
It's growing, yeah.
It's a growing surface area. And with every device that you add in, that's another door that a hacker can open to gain access to those critical systems. And with that, there's also a huge diversity between all of these devices within a hospital. So you think about all of the different medical devices that are connected in some way. It can be anything from an implantable device to a wearable monitoring device, as well as more complicated machines like MRIs, CT scanners, even syringe pumps and things like that. And with each of these different devices, the healthcare manufacturers are required to kind of look at the overall use case of this product, who's going to be using it, what kind of data is it supposed to be transmitting. And what they're supposed to do is kind of come up with a solution to protect against any security vulnerabilities that...
They got to provide guidance, right?
Yeah, they have to provide guidance to their end customers. And they just really have to think about the specific vulnerabilities that will arise from each specific device, depending on the ways it's connected and the people that will access it and things like that. And going further than that, another issue that arises with the diversity of medical devices is interoperability, which is a term that gets thrown around a lot with the Internet of Medical Things and cybersecurity. And basically what interoperability is the ability for different medical devices, whether it be from different manufacturers or just different time periods. You know, medical devices tend to have a long life cycle. So these legacy devices that are 10 and 20 years old are going to have to work in the same system that is bringing on new devices that...
And they don't always get updated.
Exactly. And yeah, they don't always get updated. And that is another issue in terms of hospital IT. A lot of hospitals don't do the best job at continuously updating their services when they need to fend off the latest threats.
Right.
But yeah, talking about interoperability, it's just kind of figuring out how to get all of these medical devices to work together in an ecosystem in a safe and secure way where they can transmit the data that they need to. And it's done in a way where all of the data is normalized to each other and it's all protected from unauthorized access. So aside from just security, you have to normalize all of the data, because if you say you have a medical weight scale in a hospital that connects to your EHR, your electronic health record, and it records somebody's weight as 170 pounds, and that number gets stored in the records, and then later, maybe it's after surgery or something, a syringe pump is assigned to that patient, and the syringe pump, a lot of the times now they kind of come with functionalities to provide dose recommendations and things, and it sees that that person weighs 170, but if that syringe pump device thinks that that number is in kilograms instead of pounds, for example, then it's going to throw your dosage way off. Exactly.
Okay, so data standardization.
Yeah, and that isn't necessarily a huge problem right now, but it's just one of those things that you have to think about when you're putting all of these devices from different parts of the world and different manufacturers all into one place, especially when it's health on the line. Another challenge that cybersecurity and the IoMT ecosystem faces is managing the security of a device over the entire life cycle of that product. So kind of what we mentioned earlier, IT services historically don't have the best record of maintaining updates on systems and updating software a lot of the times is what can allow vulnerabilities and security that get exposed after the device has been released to be patched.
Right, they probably don't spend time thinking about it because their job is to take care of patients.
Yeah, exactly. And because of things like this, and because of this growing surface area with well over 50% of medical devices within a hospital now being connected to the internet or one way or another, over half of medical IT professionals view the current security concerns as high to extreme in the United States between hospital security systems.
And the United States is one of the more advanced healthcare societies.
Yeah. And one thing that this kind of comes from is that while there are some recommendations and definitely laws put in place, especially by HIPAA, the FDA doesn't necessarily have anything specific, any requirements that medical device manufacturers have to implement in their devices to get FDA approval. And this kind of just lies in the fact that at the end of the day, it's up to the healthcare provider, it's up to the hospital to manage their own security. So they can choose to buy a medical device that is robust and secure and shouldn't have any vulnerabilities, at least in the near future, until software updates will come out to patch anything that arises. But the FDA has provided recommendations, just not requirements on how to address these.
All right, so a hospital can roll the dice if they don't think they're going to be subject to a threat.
Exactly. And not saying that it's the case, but based on the statistics, it seems like some of the time that might be what happens.
Yeah, if most medical professionals are talking about security as a problem.
Mm-hmm, exactly. So what the FDA does have to say about this is that they do have, like I said, a line of recommendations that help manufacturers manage the problem of kind of discovering vulnerabilities as they go through the product development cycle, and then trying to provide some ideas of how to secure these vulnerabilities as they go on. But they also do say that if you don't necessarily put a patch on that vulnerability, you just have to inform your customer of
know that the vulnerability exists.
Exactly. And then the customer can take the steps to avoid that unauthorized access in some cases. So I think that one thing that will change in the future is some of these regulations will come out with some more robust requirements, and especially just the shifting from solely software security in a lot of these systems to also including hardware-based security.
That's right. Yeah.
Because they work together very well, but software security on its own isn't usually a very robust system that can fend off all threats that it can encounter.
Right, and we're talking about the FDA specifically, but it is the gold standard from which other health and safety agencies take their cue from. So it starts at the FDA, but it's probably going to permeate most of the other health agencies around the world.
Yeah, I would assume so. And the FDA is definitely taking steps. They understand that this is a problem, but from their point of view, their job is to make sure that the devices that are rolling out onto the market are safe and effective for people to use, and they can accomplish that goal while maybe still having some security threats. So it's just something that will need to be figured out as the FDA progresses through their options with this. But of course, it also needs to consider HIPAA laws, which I think I mentioned earlier doesn't necessarily focus on cybersecurity or medical devices in any way, but it does say that you need to keep protected health information secure. And that's where a lot of these hospitals really want to focus on making sure that the products that they bring into their hospital and that connect to their secure systems are secure themselves, because when there are those data breaches, that's when they're in violation of HIPAA and often have fallout because of that.
Yeah. HIPAA adds a layer of complexity.
Mm-hmm.
How does Microchip contribute to advancing security in the IoMT ecosystem?
So first of all, as I mentioned earlier, hardware security is kind of the gold standard in terms of protecting a medical device and ensuring that the vulnerabilities that may be associated with,
as opposed to software.
Yeah, as opposed to just purely a software system. And at Microchip, we provide a suite of security products that provide flexibility that can fit any of these medical end products, no matter what the use case may be. So it starts with a range of products to choose from that offer different levels of hardware security for authentication, secure boots, device lifecycle management, and more. And then coupled with our crypto auth-lib software support libraries that can help manufacturers work quickly through the time it takes to add this kind of product to their system. And then on top of that, we also have a range of provisioning services that can help you set up these accesses that are approved through these chips in the field. And we also have options for security embedded in MCUs, MPUs, and FPGAs for kind of a convenient all-in-one solution. And we see those being effective in systems that are worried about form factor, like wearables that might not want to put another part on their PCB.
Right. So logic and control are protected. Mm-hmm. What are some emerging trends in IoMT?
So some emerging trends that we're seeing include the shift to kind of wearable devices and that require miniaturization and low power. So that's kind of where some of those all-in-one security systems can have an edge, as well as increased adoption of wireless connectivity, which makes sense for the Internet of Medical Things. But this is through a variety of protocols, depending on the application, whether it's Bluetooth, Wi-Fi, Zigbee. And we also have solutions for RFID and ultra-wideband wireless as well. And then additionally, artificial intelligence and machine learning edge computing is becoming a very important part of this ecosystem, especially with all of the new data that's being collected. It allows for better processing of this data that can give healthcare providers better kind of directions on where to move and where to
as you said,
improve.
it's lots of data and lots of different types of data that all needs to be
Exactly.
integrated.
Yeah. And so a big push right now is trying to just see how we can get the most out of that data to really improve the future of healthcare. And AI is definitely a big part of pushing that. Mm-hmm. Mm-hmm. Additionally, advancements in sensors and imaging systems to allow for more clarity in different biosignals, as well as just clearer imaging that improve diagnostic capabilities, especially when it is, in some cases, like an AI or a machine learning algorithm that's scanning through those signals and images to come up with a diagnosis. And then, of course, advancements in security is a big part of advancing the Internet of Medical Things. As more things come online and as more security threats emerge, more robust advanced security will be required to combat that.
Right. So we talked earlier that the FDA wants you to be aware, mm-hmm. and they're making advancements in how they form disclosure rules, and they want to make sure that the product is safe when it goes to market. But I have to assume that regulatory agencies are trying to take some steps to address security concerns. Is that correct?
Definitely. And like I said earlier, that's why the FDA did release a guidance. It's a document that walks you through what should be considered with cybersecurity, what different kinds of threats may be encountered, and the different types of security that should be implemented, whether that be authentication, secure boots, authorization, things like that. There are some additional standards that are being created from other organizations. Some of these include things like interoperability standards that medical devices can implement to ensure that they're able to communicate with those other devices.
These are codified? These are in writing? And
Yep. And some of them are being adopted on pretty wide levels, but again, none of them are required right now by
recommendation.
They're all recommendation. And so some are gaining a lot of popularity. For example, HL7 is an interoperability protocol that is probably gaining the most traction and has been around for a little while now. So as more of those start to emerge and there's kind of more of a consensus on what exactly should be followed, I think that there will be, in the near future, kind of a more secure ecosystem around hospitals to ensure that these vulnerabilities are monitored a little bit better.
What kind of devices apply to the applications we've been talking about today?
So on the medical side, it's really applies to any kind of connected medical device. We've been mentioning a lot about hospitals, but the Internet of Medical Things, it goes beyond that to devices that you find in your home or you wear with you all the time.
Fitbits and
Yeah,
other
exactly.
wearables. Yeah.
Fitbits, things like that. Or like continuous glucose monitors, things like that, digital weight scales that you can keep in your bathroom at home. A lot of these are becoming more connected and sending data directly to healthcare professionals. And again, just the more connected a medical device becomes, the greater potential for the threat there. But at the same time, the more connected it becomes, the greater potential for improvements in healthcare. And just
Kind of a double-edged sword, huh?
yeah, it really is. And then as far as microchip devices that apply, this includes our crypto authentication family, which includes our ATE CC608, ECC 204 and 206 parts, as well as our SHA 104, 105, and 106 products. And these are all small, very low power devices that provide hardware-based secure storage for secret keys. And they work with any MCU or MPU, whether it's Microchip or another provider, to provide flexible solutions for securing Internet of Things devices. And as I mentioned earlier, these devices are easy to configure with our CryptoAuthLive software support. And it's a very flexible solution. So while there are a lot of different ways to approach security depending on your application and its use case, Microchip provides a solution for all of those.
Yeah, our trust platform's a big one, right?
Yeah, exactly. So our trust platform is our provisioning service that just allows for a range of different options for our customers to choose whether they want full control of what they're doing or whether they want an easier solution for Microchip to do it for them. And we do that in a very secure and robust way, of course.
Flexibility, adaptability, and scale. That's great. All right, so suppose one of our listeners might have a use case for this technology. Where would they go and how could they adopt it?
Yeah, so we actually do have a page to talk about our Internet of Medical Things solutions, and you can find that by going to our homepage at microchip.com and then selecting Solutions, Internet of Things, and then Smart Medical. And the link will also be in the episode notes for the show.
I'll make sure it's in the episode notes for this show.
And additionally, if you want to learn more about our security products, you can go to our homepage and select Products, Security Products, and Crypto Authentication.
And we'll make sure that link's available as well. At this point in the show, we typically ask for predictions. So let's talk about medical, Internet of Medical Things, probably a little bit of AI and machine learning in there. But what's next? What are you looking forward to? Are there any trends that you've identified?
Yeah, so I think really the biggest thing that will come out of this evolution to the Internet of Medical Things that we're seeing with all of these devices being connected is just the increase in medical data that's available, that these, like you said, AI and ML algorithms will be able to go through and really find connections between a lot of different health metrics that we might have not realized had a correlation before. So this has the potential to open doors for improved management of chronic diseases, as well as personalized treatment plans and even predictive healthcare. And some things further down the line, which is kind of like the medical future, is precision medicine and genomics. So eventually you'll be able to get your genes tested. And based on all of this data that's been collected and processed, we'll be able to determine what diseases you have the most risk for based on your genetics. Or
Customized preventive care and customized medication?
Exactly.
Wow.
And so while it's definitely pretty far down the line, eventually we might see a future where we can figure out what diseases people will get before they get them and stop them before they happen.
Yeah, well, more data, right?
Mm-hmm. And additionally, this will future just research and innovation within the health sector that will just open new doors to understanding disease mechanisms and the effectiveness of treatments.
Any final thoughts?
Yeah, so I think that the potential for the Internet of Medical Things to improve the quality of life as well as the access to healthcare is extremely high, but the transition will require robust security solutions, as well as improved regulations and standards, and improved interoperability. And all of those things will need to happen to be able to reach this potential. If these can be achieved and the risks are able to be minimized, the risks that are associated with sensitive patient data and health critical devices, then I think that the future of healthcare is very bright through the Internet of Medical Things.
Well said. Thanks for coming on, Justin.
Thanks, Dana.
Justin Wilson is a technical marketing engineer at Microchip Technology, working out of the Medical Products Group. He joins us today from our global headquarters in Chandler, Arizona. Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.